Hi, in this video we're going to try this problem. It reads, on the Timm's test in a recent year, the U.S. scored an average of 508. Suppose we take a random sample of n U.S. scores and that the population standard deviation is 72. If the probability the mean of the sample exceeds 520 is 0.0985, what was the sample size? Okay, I took this book problem from section 6-3, edition 10 of Alan Blumen's book. This is number 25. And also, in the problem, he provides a whole bunch of other test scores, just as a, by the way, all they are is a smokescreen of extra information. So all I've written here is exactly what we need. So let's take a look at this. And notice here that we're talking about the probability of the mean of the sample. So let's try this. So when we have the mean of the sample, remember that is x bar, and it also means that we need the standard deviation of the sample, which we call the standard error of the mean, is going to be based on sigma divided by the square root of m. So using that, with that in mind, let's see how we can tackle this problem. The first thing we have is this. It says if the probability of the mean of the sample exceeds 520. So in math notation, this is the probability that the mean of the sample, x bar, exceeds 520. Oops, 520. That's a 2. Exceeds 520. Notice it's not very much. It's 0.0985. So if we take a look at that, let's draw a picture of the normal curve. Okay, so here's my picture of my normal distribution. And notice that the probability of being above 520 is 0.0985, a little below 10%. So if I'm going to shade in this problem, then I'm not going to be shading very much. As a matter of fact, I'll probably just be shading maybe even a little less than this, but for the sake of illustration, it's just a small region of this total picture. This is my 520. So let's go back to black here. So here is x bar is 520. Now, let's see this. Also, it says that if we have 520, then we have this area down here is 0.0985. Okay, now, if this is 0.0985, if I shaded the entire picture, I would be shading 1. So to find the unshaded region, all of this in here, this is going to come from 1 minus 0.0985. And I believe if you work through that, and we don't make any mistakes, you get 0.9015. Now, let's find this area. So let's do this. Find the z-score that coincides with this area. That coincides with this area. Okay, now I'm going to go back here, and I actually have a table of z-scores. So I'm going to pull that up now. And now notice that in this one you see that the area, I'll use a different color, red. So notice that this one always begins on the far left. Begins, and then it goes up to whatever this value here is, up to. So in this case, I only go up to 0.500 right here. So we can do better than that. So I go to my next page, and let's see if on this we can 9015. Let's see, here's 9306. We need to be a little smaller. Look at that. And if we highlight this right there, that is the 9015. And let's see, let's highlight this. It goes from the row that corresponds to 1.2, and it corresponds to the column of 0.09. So using that, we can use this. So let's go back up to our other problem. So this says that for 520, it coincides with z being 1.29. Now, we only have one formula in this section, and that's what attaches the z-scores to the data values. Or in this case, data values are groups of data, that mean of a group. So really, I'm looking at x bar minus mu divided by the same standard error of the means. So this is also could be written as x bar minus mu divided by sigma divided by the square root of n. Okay, now let's see what additional information we have. And that is this. We have this piece. The mean for the US is 508. So what they're saying is, wow, you had a group that had an average of 520 or better. That was a pretty exceptional group. Like if you were the teacher and that was your group, you should be proud. Or if you were one of those students, again, you should be proud. So now we have all of these pieces, and I'll write these out. We have found that z is 1.29. We've found that x bar, our unique group of wonderful students, scored 520, or averaged 520. We have the mean, the mu, is 508 for the entire population. We have sigma they gave us to us as 72, and what's missing is n. N is needed. Well, if we have every single piece but one, we can solve this. It's a little bit of an algebra problem. So here we go. Let's try this. So 1.29 equals x bar, that's 520, minus the mean. We have that as 508. Take all that, we're going to divide it by 72 divided by the square root of n. Okay, now in algebra, the one thing the one rule is that you can do whatever you want, provided that whatever you do to one side, you do the exact same thing to the other side. So I'm going to start out, and I'll annotate my steps in red. It's nice and bold that way. So what I'm going to do is I'm going to multiply the left hand. Oops, that's an ugly 7. Let's do this again. I'm going to multiply this left hand side by 72 over square root of n. So if I multiply the left, if I multiply the right, I also need to multiply the left. Okay, now let's see if we clean up. We have 72 times 1.29 divided by the square root of n equals, well, 520 minus 508 is 12. And notice that this fraction and this fraction are going to cancel, so now I'm left with a 12. Okay. Now again, we can do the same thing. Let's multiply both sides by the square root of n. If I multiply the left side, then this will cancel on the left, but I have to do the same thing over here. Okay, so now if we take a look at where we're at, now we have 72 times 1.29 And I'm using my calculator here, 72 times 1.29. Oops, sorry, let me try that again. Times 1.29 is 92.88. So here we go, 92.88 equals 12 times the square root of n. Now what we want to do is we want to get the n by itself, and we'll get it all by itself in a moment, but the first we'll start with clearing out that 12. So then if I take my 92.88 and I divide it by 12, I get 7.74 equals the square root of n. And then to remove a square root, you square. So I'm going to square the right-hand side to remove the square root. So the left-hand side has to follow along. So then if I square 7.74, I get, let's see, get this back. So the 7.74 squared is 59.9076. And then if you think about this, you can't take 59.9 test scores. So really, the sample was of a group of size 60. And you're just seeing some rounding error.